Assalamu alaikum, everyone, and welcome to yet another session of the from the series of free webinars that we are arranging for you people. And this session is basically part two of the session that we conducted previously, which was on data entry in SPSS. And in this particular session, we'll be discussing about descriptive analysis in particular. And it is a request to everybody, please keep your videos off and turn your mics off as well so that the learning experience is uninterrupted and better for everyone. And with this note, I'd like to hand over the virtual podium to our respected facilitator, Professor Dr. Asif Hanif, to please start the lecture formally. Thank you.
Assalamu alaikum to all of you. Welcome. Today's session is on descriptive analysis using SPSS. As Ms. Tyra told, this is the extended version of the previous session that was on data entry on SPSS, and we had already session exporting data from Excel to SPSS. So when you have entered your data, when you have exported or whatever you entered yourself from your questionnaires, if you have entered your data, you can analyze very easily if you give appropriate commands to SPSS. First of all, you need to learn that SPSS does not know how to analyze data. This is human-directed, actually, technology. Whatever you will say to SPSS, it will perform. So it is always wise to learn about the appropriate statistical techniques according to the types of data. So let me give you some tips or examples. As you everyone know, the types of data is quantitative and categorical. In my very first webinar, I gave the concept of type of data that was quantitative and categorical or qualitative data. For quantitative data, we had different statistical analysis plan. For qualitative data, we have different statistical analysis plan. So as soon as I perform the analysis, I will tell you about these tips, which analysis is suitable for different kind of data analysis. If you see at the variable view where I had constructed the questionnaire, these are the list of variables. Like first variable was, for example, city, then study groups, then age of mother as categorical data was also taken, age at marriage, age of father, body mass index, profession of mother, neonatal gender, neonatal weight was also taken as quantitative and categorical data. If you see the measurement scale where the coding was done, it means it is closed-ended question, and for all closed-ended question, the type of data was given as nominal or whatever the appropriate type of data was there. For quantitative data that was open, the type of data was given as scale because it is quantitative data or continuous data that was taken as number and decimal places were there. So when we were at variable view, we could generate the our performa, and we can enlist the list of variables. And if we go to the data view, here is the entry of 200 participants in this study, or 200 people who were interviewed during the study periods. You can see here 200 entries are there. I want to give you some very important tip along with the data analysis technique. Always keep your serial number as one variable in your data, because sometimes we need to make data arrangement in ascending or descending form, or we need to sort our data in ascending or descending. Then we can make original sequence of the data by clicking the serial number as sort ascending. For example, I want to see the minimum age of the mother. What was the minimum age of the mother? If I come here on the age of mother, I right-clicked and sort ascending, press the sort ascending. You can see here, I could find a typing error, maybe 13 year is not sufficient age of mother that was taken as I intentionally wanted to tell you these ages can be for example, typing error, like some other errors. If later when I confirmed from my performer number 161, this was actually 30, it was not 13. Okay, so I corrected it. For example, I want to see the highest age of my data. I did the sort descending, and highest age was 42. That is okay. Now all the data is shuffled according to the ascending and descending format of the data. So we can again go to the original sequence of the data by clicking the serial number. By serial number, and I will click the sort ascending. You see, again, the data is sorted out by the original sequence of the data. So for example, you want to analyze this variable that was study group or that was prevalence of preterm birth in Punjab. When this data was taken, we calculated the preterm birth. We actually measured the frequency or prevalence of preterm birth in Punjab and different cities, different provinces and cities of Pakistan. But here I have taken only data of Punjab to just the practice for statistical analysis. If I want to present this data, there are two types. Remember, when we have categorical data, we can make tables and we can make graph of the data. Among the graph, pie chart is an appropriate type of data analysis for categorical data. If we press on graphs, legacy dialog, pie, you can see here the graphs I told in my very first, I think, video that was descriptive statistics. You can see here we can make bar, line chart, area chart, pie chart. We can make scatter diagram, histogram. Because I have told you for categorical data, when there are less categories, pie chart is an appropriate statistical technique to analyze the data. So go to pie chart, define. I want to analyze my data as study groups. Click this study group and shift in define slice by. This button will help you to shift the data in define slice by. If you want to take out this data from this pane, you can again click this button and it will take out the variable. Again, you can shift here. So press OK. Look, this is my data sheet, and this is output sheet that was another window. So in output sheet, you can see the pie chart is made. Do you think this pie chart is okay to use in any research manuscript or in any thesis or any article? Pie chart, define slice by. I shifted my study group or preterm birth here in the define slice by. Press OK. Here is the pie chart that is made by SPSS, but no frequency and percentage is given on the slice. Is it okay? Can you see? Okay. If you double click here, go to element, show data label, you can put this percentage on the display window. Just apply. Here is the pie chart that can be used for any research manuscript. If you explode the slice as well, you can see the chart is more attractive now. Is it okay? Can you see now? Okay, visible now. Okay, let me see. Okay, then for example, we want to make any bar chart. Again, go to graphs, legacy dialog. Here is the bar. Okay, We were there at define graph. Legacy dialog, bar chart. Here is the simple bar chart. Press define. You can make bar chart for any categorical data that has more categories. For example, I am going to make body mass bar chart for body mass index. If you click here, the category axis, just press OK, the bar chart is here. So you can see the bar chart is made, but there are no number and percentages displayed on the bar graph. If you double click again, this chart editor will be open. Go to element, show data labels. Counts are already there. You just press percentage and shift on the above displayed window. Press apply, close this window, and here is the bar chart to use in any research manuscript. So for quantitative data, so remember, for categorical data, pie chart and bar charts are appropriate statistical techniques or graphical techniques to be made. Usually we make histogram, we make scatter plot for categorical data that are inappropriate. So again, go to graph, legacy dialog, go to, for example, bar chart. Again, I want to make cluster bar chart. For cluster bar chart, go to define. Suppose we want to see the study group in relation to mother's body mass index. Look, I shifted one variable in categorical axis and other variable as cluster. Just press OK. You can see the preterm birth is given with respect to mother's body mass index. Again, you can double click. This will be opened in chart editor. Go to element, show data label, along with the percentages or counts, press the percentage, press apply, close it. All the number and percentages are there. Please mute yourself. Please, it is requested to everyone mute yourself. Okay. For example, we want to analyze any quantitative data, that is, you can make histogram or you can make box plot. For example, I want to make histogram. Go to legacy dialog, histogram. Here is the age of mother, put into the variable, display normal curve, press OK, histogram is made. So here is the histogram that is made for quantitative data. If you cannot see the input window, no problem. My input window is already filled with data. I am showing only how to apply the statistical analysis. Definitely in my input window, there is data, but you can analyze all the data by staying even in output window, okay? So in legacy dialog, all the graphs were there. We just made pie chart, we just made bar chart, we just made histogram. And histogram is made for continuous data where we need to see the distribution of data. If you see, the bell shape is pretty well. It is looking like a normal shape. But if it is looking like a normal shape, normal mean bell shape, it doesn't mean data is normal. For data is normal, we need to test the data. For testing the normality data, there are multiple tests available that I will, inshallah, in coming webinars, I will clear and I will conduct for normality of data as well. So for other statistical tool, like we want to make box plot. For box plot, you just go to simple, define. Let's suppose I want to see the outlier in the age of mother. Box plot is used to see the outlier in the data. You just press again categorical axis as study group, press OK. It will tell you about the outliers among full term and preterm birth. If you see, the case number 83 is outlier. If we go to data sheet again, let's see what is the age at the number of 83. Go to data sheet again and see the case number 83. Here is the case number 83, that is 44. So age of mother as 44 is considered as outlier. But biologically, if it is okay, do not deal with this number. You have to keep this number here. In statistical techniques, we can also deal the abnormality of data, and we can do some statistical measure as transformation of data. But here we do not need to transform our data. So there is only one outlier. So again, if you want to make analysis like line chart, for example, define age of mother as, for example, category axis. If you press, here is the line chart. You can see the age between 29 to 31 as 30 is one of the highest age in the data. It is requested, please mute, everyone mute yourself, please. Okay, again, go to graph. We can make graph, legacy dialog, line chart. For example, we want to make multiple line chart, define it. Again, age of mothers. And for example, if you want to split it as a study group, you can see the comparison between full term and preterm and age of mother. Almost the age 30 was at peak in both, but here if you see the preterm, there was no preterm among the early ages, and as age was advancing, there was variation. And if you see at this age, preterm birth was more as compared to full term. So if you want to make table of any data for, okay, one more graph, that is scatter plot. Scatter plot is used to see the correlation or a relationship between two variables. For example, if you put simple scatter plot, define, let's suppose neonatal weight is dependent variable, put it in y-axis. And here, suppose age of mother. Neonatal weight is depending on age of mother. So if you see, if there is any trend, like if you see this kind of trend, it is positive relationship. If it is like this, it is negative relationship. What is meant by positive and negative relationship? Positive relationship means if one variable is increasing, the other is also increasing. If one variable is decreasing, other is also decreasing. This negative relationship means if one variable is increasing, the other is decreasing. For example, we want to see the real scenario, what is actually the trend in the data. If I double click it, if you see, when I double click it, it is opened in chart editor. And if I press this button, this line, add fit line total, there is no trend. So the age of mother has no impact on neonatal weight in this data. Or if it is if it has, it is slight negative relationship, because if you see, it is starting and there is a little slope and it is coming from upward to downward. It's negative relationship, but visually it is looking that there is no relationship. So if you want to make any table of your data, you go to analyze, descriptive statistics, frequency. For example, you want to analyze age of mother as categorical variable and you want to make any table of it, you just press OK. If you see, this table is showing there are 177 who has age less than 35 and 23 had age more or equal to 35. Again, go to analyze, go to descriptive statistics, frequencies. You can put more than one variable here to make the table of the data. For example, look, and it is suggested if you want to make table, do not shift quantitative data. I'll shift just to tell you what it happens if we make table of any quantitative data. Look at how it is easy to interpret. There were 151 full term, 49 preterm. There were 7 females who were underweight, 85 were normal weight, 65 were overweight, 43 were obese. So if you see, everything is very clear and we can interpret it in very good manners. What happens if we put quantitative data and make table? There will be no appropriate information to interpret. Look how long this table is. Only we can see the maximum or minimum number of any age. If we see, there were 31 female who had age 30. So rest of the ages can be seen, but this is inappropriate to put in any research article or in thesis because there is no good information. Yes, for quantitative data, if you want to make it very meaningful, you need to calculate mean, standard deviation, medians, and interquartile range. So again, go to descriptive statistics, go to frequencies, go to statistics. Here is mean, here is standard deviation, here is minimum, maximum, range. You just press continue and uncheck this button, display frequency table, because I do not need frequency table for quantitative data that has huge numbers, because it was an open number and every participant possibly have their own ages and it can be different from one another. So if I put all these information and in the statistics, I have already clicked which kind of statistics I need. For example, I put median here as well. Continue, press OK. Now look, no long table is made, but their mean, median, standard deviation, range, minimum, and maximum is given. So for age of mothers, age at marriage, age of fathers is calculated as descriptive statistics, because for quantitative data, mean, median, standard deviation, and all summary measures are appropriate to calculate. If you again go to analyze, go to descriptive statistics, despite going to frequencies, you can directly go to descriptive and put your quantitative data into the variables box. If you just press OK, it will calculate some descriptive statistics that were checked by default. For example, I checked it. I clicked it. Look, minimum, maximum, mean, and standard deviation is calculated. It can be changed if I again go to descriptive statistics and descriptive. If you go to options, look, here are few other statistics are available. Like I can calculate range, but there are not as much as options available. Those were available in the tab of frequency. If you again go to frequency, here is the statistics. See, variety of statistical analysis technique is available. Even if you press the quartiles, Q1, Q2, Q3, and medians, it will be calculated. Press OK. Here is the descriptive statistics for quantitative data. So this was all about the analyzing the data in a descriptive manner. For categorical data, you need to apply table or graphs. Among the graphs, only pie chart and bar chart are appropriate for categorical data. And for quantitative data, you can make variety of graph like line chart, like scatter, like histogram, whatever I told you. But it depends on objective why you want to do such analysis. If you want to see the distribution of data, you can analyze through histogram. If you want to see any relationship between two quantitative variables, you can apply scatter plot. If you want to see the outlier, you can go for box plot. So thank you very much. If you have any question, you can ask. But raise your hand, please. One by one, you can ask the question.
सर मेरा एक क्वेश्चन था
जी प्लीज.
सर एरर बार चार्ट भी होता है वो उसका जरा समझाते एरर बार चार्ट.
Okay, if you go to analyze graph legacy, if you go to bar, go to simple, define. Already body mass index was there. Go to option. Here is the display error bars. In the same way where you made the bar chart, if you go to the options, just press display error bars. Press continue. Press OK. If I show you the analysis, here is the error bar chart that is made. Is it okay? Okay, next.